Mark P. Otten back with you. Okay, this is your dependent samples, one independent variable ANOVA in R. You could also call it repeated measures or one way. Lots of ways to declare this as a one independent variable situation where the independent variable samples are dependent on each other, in this case by repeated measures, the same measurement or the same people being measured repeatedly over time. And so here we go. Okay, so the first step is to, I'm showing you SPSS data actually here. And the reason I'm doing that is because there is a format switch that is required when you go from SPSS to R. So on the left is the data format that we used when we entered this into SPSS. This is part of my dependent samples ANOVA video. We have 3 time points for this particular data, and the ratings are: how threatened do you feel by the sight of Neil Patrick Harris's face in a photo? That's what this data represents. So over here on the left, you've got the format that we used before. Pretty simple. I mean, relatively simple, I think, because you've just got 3 columns of data, and each one represents a time point, and going down the rows, each row represents a person. So we used that, we got our results in SPSS. Now, however, we need to convert to the right side, which is the R preferred format, which requires a little bit more data entry, but hopefully you can sort through without too much trouble here. So we still have, it's the same data, so we still have 3 time points, which are represented here in the second column now. Instead of going across the columns, you just put all the data, the ratings here into one column, and then you label them by time. So you've got the first 4 ratings there are from the first time point, and so on. And then you've got this additional column here to represent which person it was. So for example, row 1 is person number 1, time number 1, a rating of 7. That's the value in the top left if you're looking at the data on the left side by the old format. Second row here is person number 2, time number 1, rating of 5. So that's this person here. So it's the same data, just there's a little bit more labeling going on. So you're going to take the one on the right, the one that's now in the slightly more complicated format, and you're going to import that one into R. And so I'm going to open up R now and show you what it looks like here. This is your data set imported into R. No labeling required in this case. There's some labeling you can do if it helps for your variables, but in this case we just have 4 people, 3 time points, and then the rating for each one. So you import it there. Given that it's in that format, this code then should run smoothly, hopefully. Cross your fingers for you. That was a crossed finger, not a obscene gesture in the middle of my video. Don't worry, my fingers are crossed. Anyway, I would never do that. Okay, so the first line here is just calling in your data set. I don't know why it's attach, but it's attach parentheses and then the name of your data set, which in this case is, what did I call it? X1 IV DEP for ANOVA for R. Okay, so then line number 2 and line number 3 are declaring person and time as factors. This is key for just R to know that this is going to be a dependent samples situation instead of an independent samples situation. So I called it person and time for the labels in the data set. So person then is like, it's the person, and then left arrow factor parentheses person, and then same thing for time on line 3 there. So that just depends, like what you put in there and the parentheses and everything just needs to match and represent what you put in your data set for the labels. And then the actual running of the ANOVA occurs in line 4 here, where you put results, left arrow, AOV, parentheses, and then you just got to remember to put your DV on the left. So DV is rating in this case. And on the right is time, that's your IV. And then you're putting a person in there, but you're putting that in this error term. So this is like necessary again for a dependent samples ANOVA situation. So the DV is rating, that goes on the left. The IV is time, that goes to the right of the tilde. Should I explain what a tilde is? Tilde is on your keyboard. It's like if you're looking at your keyboard, the number 1, it's the button to the left, and you capitalize that. That's what the squiggly line is. Okay, so dv tilde iv plus error, and then in the error parentheses here is person/time. And again, this whatever you call, if you called it something other than person, you just need to be consistent with what you call it here. And then the last line will give you summary, the summary of results if you type it in like so. So you just run it from there, and you're going to get your results down here. You're going to get your f value 15.71, your p value 0.004. We are rejecting our null hypothesis here and concluding that time does matter. And we saw the same results in the SPSS. So if you're working on your homework, you just got to match up your R results to your SPSS results, and you should be good to go.